everybody, it's Patrick Fitzsimmons back here with another video on the MIT's I²C Eeprom Byte Banger. So in the last video, it was basically just an introduction to introduce you to the Byte Banger and how to put it together and where you can get the code on the Instructables website. And so I thought in this video we would take a look at what it does. And so starting out here, this is the image. This is one of the images I have on the Instructables website for you to follow as far as how to hook up your breadboard. And you might notice a couple of errors here. First, if my mouse cursor is showing up, you can see this stray red wire here connected to plus 5 volts and going to nowhere. Basically, this was for a prior component that I had on the board that I just forgot to remove this one wire, so it's no big deal. It's not going to affect anything. The other thing is you'll notice all of the EEPROMs, pin 7 on all of the EEPROMs is not connected, it's floating. And so pin 7 is the write protect pin. If you tie that to ground, that means we can write to the EEPROM, and if you tie that high to VCC, write protect is enabled. And so on the breadboard, it doesn't seem to matter if we leave that floating or not. I guess it's always good practice though to tie that either high or low, and so in this case, if you want to tie that to ground, since we are going to be primarily writing to the EEPROM as well as reading from it, so you could probably hook that up to some other logic to switch that, which I don't think it would be necessary here on the breadboard, but if your EEPROM is going into another application, say a data logger or something to that effect, you would definitely want to make sure that write protect is either enabled or disabled depending on your application. So I just thought I would just point those two little mistakes I have here in the photo out. And so we can go over to the Byte Banger. The code here, it's pretty extensive. It's about, yeah, it's over 1,000 lines of code, and there's quite a bit going on here. And so instead of going through the code and trying to explain what we're doing, let's just go right into the application and see how it works. And so I just want to point out that the sketch does use quite a bit of storage space on the Uno 91%, because the Uno only has 32 kilobytes of internal program storage space, and of course we're using about 66% of the dynamic memory. So there's not, I mean, we could reduce the code. I could always take some things out if I really had to, but I'm happy with the way it is for the moment. There are a few things I might change in the future. That's why it's only version, well, this is version 0.7.1. I think uploaded 0.7.5, and so yeah, so there's room for expansion here, and perhaps adding some things and taking some things out. And so if we, let's see here, so we've uploaded the code to the Uno, and here's the serial monitor, which is basically where everything happens. And so I'm going to close the monitor out just so you can get an idea of what happens when we start the program from the beginning. And so in order to do that, I'm going to have to tools, serial monitor. I guess I could. So you can see and hear, hopefully, that we did a scan of the I²C bus to find if any devices are located at the addresses for the EEPROMs that we're looking for. And indeed, all 8 EPROMs were located. And so it brings us into, I'm going to fix that. That's giving me a double menu. It's not really a big deal. But it brings us basically to our main menu. And so a couple of things I want to point out here. First is right down at the bottom of the serial monitor, you got on the right hand side a little drop down box. This drop down needs to be set to no line ending. That's very important, otherwise you'll get some garbage through the serial monitor. And then of course make sure that your baud rate is set correctly. The default baud rate is 115/200. It's worked out fine for me. I know a lot of people will set it to 9600, and that just seemed a little bit slow. And I've had no problems with data transmission at 115/200, so I haven't anything higher than that. I've not tried it. You're welcome to play around with that if you like. And so aside from that, you can see we've got the MITS I²C Eeprom BYTEBANGER, version 0.75. And then we've got this little boxy thing here with some information, and then our main menu. And so this little boxy thing is basically, it's our status window. It's telling us all of the information about the EPROM, about our modes, safe mode, read mode, write mode, and the SD card. So the EPROM address by default is set at 0x50. Now the type, you can see it's not set. We've got this little degrees circle-y thing here. And then you can see these little circly things down here. And so that basically means, it's just a notifier to say, okay, we can't do any of these options in our main menu because this is not set. The type has not been set. So we really can't do anything at all at this point. And you can see we're coming up with some null characters on our serial number, because we do have an option to write a serial number, as you can see here down, option number 9. If we want to plug in a serial number, so we can do that. Now our safe mode is on, so this is safe mode emulating the write protection mode. So if safe mode is on, that basically means we are write protected, so we won't be able to write to the EPROM at all while safe mode is on. And then of course we got a read mode and a write mode. The read mode essentially is attributed to what we're going to see in the serial window, data coming back from the EPROM. And then our write mode is going to be attributed to what we're going to write for output to the SD card. When we decide to dump information out, we can dump it out in ASCII or decimal or hex or binary or octal, actually. So we've got all options there for both read and write. And then you can see, yeah, this SD card is ready. And so that means that we have an SD card in the SD reader, and it is all set to go. It has been initialized, and so we're ready to write to the card. However, the only option we have available at this point, since the type is not set, is our settings from our main menu. So we're going to have to set that type. And so option 0 is settings, so we type that into the serial monitor, and that'll bring us to our settings menu. Now, of course, you can see the status window will appear on all menus, so we can always see what's going on. And so in our settings, we have a, choose an option below or type X to exit, and that'll exit back to the main menu. And so our options here is auto detect the EPROM, which I'll talk about in a second. The set EPROM type, set EPROM address, initialize the SD card, then set the read mode, we can set the write mode, and then we can turn safe mode off, and then we can write to the EPROM. And so when I started writing the program out, I was setting the EEPROM type and address manually, and then I realized, at some point during writing some other functions, that it would be a lot easier if I could just auto-detect the EEPROM, and so I wrote a function to do that. And so what that does, without really going back into the code too much at this point, I want to kind of stick with the window here that shows you what we're doing. But it's going to write to the EEPROM, even if safety mode is on. It's going to write to address 0. It's going to go through a function and determine how many bytes are on the EEPROM, what size the EEPROM is, and then it will do all of the magic for us and set it up. And so you can set the EEPROM type and address. Well, that the address has nothing to do with the type. You can set the EEPROM type manually if you don't want to write to location 0 on your EEPROM for any reason. Let's say if you have that reserved for another purpose, then you can always set your EEPROM type manually, and you won't have to worry about auto detect overwriting anything on your EEPROM in location address 0. And so I will auto detect the EEPROM. Just type 0. No, you type 1. Auto detect into the serial monitor. And it's going to give us a little cat call saying auto detect found a 256K bit EEPROM at address 0x50. And so now you can see our type is set here, 256K bit EEPROM, which gives us 32,768 bytes. Safe mode is still on, but we can type exit at this point just to go back to the main menu, and you gotta click into the window just to see what has changed. So now from the main menu we can see that safe mode is still on, but we have opened up everything that had that little degree symbol next to it. So all of the things on basically from 0 to 4 have opened up for us. Now from 5 to 9, so basically everything on the right side of the menu, we have this little happy face that tells us that safe mode is on, and so we're not going to be able to do these options while safe mode is on, because basically every one of these options is a write option, and all of the write options are on the right. As we can see our little happy faces there. And so basically all of our read functions and of course our settings are on the left here. And so our first option is the SD file list, byte scan, range read, read EEPROM, and then we got EEPROM to SD, SD to EEPROM, save settings, range write, and then a write serial number option. There's also another option that'll appear down here when safety mode is turned off. So it's a hidden option. It's not available to us at all at this point, just like these. But I just felt I'd leave that option out until safety mode was actually turned off. So let's go back into our settings, and then we'll turn safety mode off, which is 7. And now safety mode is off. You can see here up in the status window, you can see our option 7 now has changed to turn safety mode on if you want to put back the safety mode in place. But we're going to exit back to our main menu, and now you can see we have this option down here which is in our bar blocks, and it says type E to erase EEPROM, and so that's going to erase the EEPROM entirely based on what size it is. And yeah, so I figured that would be sort of like a hidden option until we're actually ready to do any kind of writing. And just so by mistake it wasn't on the number pad, so you wouldn't, I actually originally had it as number 5. Then I thought, well, I'm pretty clumsy, so I'll either hit, I'll be wanting to hit 6 and I'll hit 5, and I'll want to erase my EEPROM and just make this. So I figured Having it as a letter option, E, will really give us some protection so we don't overwrite it. And of course, there's also a safety feature that we can back out of it too. So if I wanted to erase the EEPROM, if I just type E in here once, and it's going to say erase EEPROM, you're about to erase the EEPROM, so press type E to erase or C to cancel. So we can still cancel this operation if we come this far, even by accident. And I will cancel that right now. And because actually these EEPROMs, when they come new, they're all set, or at least the ones I've got and the ones I've heard about, they're all set to 255, which is hex FF, which is, well, it's basically a 1 in all of the bits. And so I don't know if that's just because it's something they do at the factory when they make these. Maybe they do a test write just to make sure the EEPROM is actually working correctly. Check for defects or that sort of thing. And so that's why they're filled with all ones. But I would assume an empty EEPROM will have all zeros. And so then when we erase our EEPROM through this function in the byte banger, it will set all of the bytes to 0. And of course, you can change that to any number, any number you want between 0 and 255. That is always optional to change the code. So now we're okay. So we're at a point we've kind of covered the menu a little bit, and we've gotten to talk about the erase EEPROM, which was the hidden function. Our safe mode is off, and so now we have all options available to us. And so we've got the first one is SD file list, and so we can read what files are on the SD. I don't know if I have any on this. Okay, so files on SD card, we have test hex. Oh, and you can always scroll back up if it goes too fast. Test hex EPR, and then test again EPR. And so when you put in a file name, you got to make sure it's, at least for now, only 8 byte file names, and then with a 3 byte extension. The extension can be anything you want. You could have, a .txt, a .dat, a .csv. Excuse me. And I just chose a .epr because I've set that up with Notepad++ to recognize the .epr file extension, and that's just what I use to know that it's an EEPROM data file. But you can have any file extension you want. Let's see here. So the byte scan is, well, these things are pretty much what you would expect them to be. A byte scan is going to scan for a byte, and so if we're going to look for one particular byte, how many FFs do we have in the EEPROM memory, or how many, it could be any, actually you're not going to put it in through hexadecimal, you're going to put it in as a decimal number, 0 to 255, so you can find out how many zeros you have, you can find out how many ones, whatever. And so if we just do a byte scan, we'll go into option 2, and it says scan the EEPROM for specified data, and you can type a value to scan for from 0 to 255. And so if I put in 256, it's not going to do anything. It's going to give me an error. You must enter a valid number, 0 to 255. So let's find out how many zeros I have. I should not have any. It's going to scan for 0, and then it will scan through every address here. You can see how fast it's going, and we're heading up to 32,768. Of course, a larger EEPROM would have more memory addresses to scan through, and likewise with a lesser one, it would have less. And so there was 0 found of 32,768 bytes scanned. and so you can check your EEPROM for a specific value. And then you can also do a range read, which brings us to option number 3 in the main menu. And you can type a range to scan, and it's not going to scan for a particular number, it's going to scan for the range. And so if we go into option 3, you can see it says type a range using the start and end commands, and so that's basically S and E, and you would start at any value that you wanted to pull a range for. So if you want to start from address 0 to 127, which is 128 bytes, then you can put S0 E127 up here in the window, and that's how you would write your range. So you're starting at 0 and you're ending at 127, which is 128 bytes, and then you press that in here, and it's going to give you that range. So it's going to show you, and see 23 has been written to address 0, and that's the number we use for our auto detect. Remember I told you it writes to address 0, and that's just the number I chose as a default to check for while we're doing the auto detect. You can have that any number you want between 0 and 255. And so that's what a range read is. And so the read EEPROM is going to read the EEPROM, and at this point I'm going to let it read for a little while, and you'll see why I'm going to stop it, because this is another thing I just sort of put this in, and it's something I think I want to take out, because it uses a speaker, and it's kind of annoying after a while, especially with a 256 K-bit EEPROM. So we're just going to type 4 in, and you'll hear what it's going to do here. So it's going to do this. It's going to read the whole EEPROM all the way up to the end. And it's going to give this little beep, 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 beep all the way. And of course I can just unplug the speaker, but you can see how slow it goes, and that's because of the delay caused by having the little beep beep sound. So if I take that little beep beep sound out, it will scan just as fast as the byte scanner, which was fairly quick. You see we're only up at 500 and some odd bytes. I can unplug that. Actually, you know what? I will plug that back in. And because we'll just close the window, and then we can reset it by opening it again. And so it's going to bring us back to scanning for our devices, and so we can see we're not set. So we're going to have to do our setup again, which is okay. So we'll do that real quick. And 0, 1, X. And I could type 0, 1X all at once and press return, and it would do the same thing, because all that information will be saved in the buffer. Oops. I have to go back in and turn safety mode off. Okay, and so that's the read EEPROM. You can figure out what that does. And like I said, with that sound in there, I'm gonna have to take that out. And you can leave it in if you want, but you can take it out too. But I'll do an update. And so let's bring this to number 5, Eeprom 2SD. So we're gonna take the information that's on the EEPROM, and we are going to write it to the SD card. And let's see here. So we type a file name to save, and I'll just say test 22.abr. Then it's going to give us a note writing EEPROM data to SD file that we called as test22.epr. will take a little bit. There we go. So it's done. You can see I'm going to fix that so it's separated. There again, version 0.75. This isn't perfect. There is still things to do. And your input might help out too, because if you have an idea, if you're looking through the code, you can see how something might be written better. Please leave a comment or shoot me an email or whatever. So SD to Eeprom, we're going to skip that one for now because I'm going to have to manipulate the data on the card, take it out of the computer, and it's going to be something that's going to have its own video. This SD to Eeprom. But basically, what we're going to do is we're going to take a comma separated file, which we just actually created, and we can program that into either the same EEPROM or a different EEPROM or however. So our settings, we have save settings, range write, and write serial number. So let's skip over. Let's write the serial number real quick just so you can see how that's done. Option number 9, you can see right here still in our status window, we just got a bunch of boxes in the serial number. And so we're going to write the serial number. And so what that does, it's a 16-byte serial number, which is fairly typical, I guess, on these I²C EEPROMs. When they come from the factory, you can actually have them programmed with a 16-byte serial number. I think they charge you to do that. But we can do that ourselves for free. And it doesn't have to be 16 bytes. It could be a 32 byte. It could be, as many bytes as you want or as few as you would like. But I chose to go with a standard 16 byte. And so I'm going to call this a 24C 256 dash X. No. So we're going to put 1919. It's like the week. I think it's the 19th week, or maybe it's the 20th of 2019. And then I'll put an X because this one is erased. Actually, I haven't erased this one yet. No, this is new. I'll put an N and 0001. So that gives me 16 bytes to write into our serial number. And so we'll do that. It will write the serial number in, and it writes to the last 16 bytes of the EEPROM, so the very last EEPROM addresses. And if I do a range read, instead of a read EEPROM, so we can get through it quick. So we're going to start at 0 and end at 32,768. It's going to read. Uh-oh. What happened? I think I'm getting a delay because it's reading it before it's giving it through the serial monitor. Give it a couple seconds, and there might be another bug to fix. So, like I said, this code is pretty extensive. It was a mess for a long time as I was creating different functions to sort of do something different that I wanted to think of an idea. It's like the range read and the range write. It's like, add these functions in, and of course, now that I'm on stage and firing it up, it's not working correctly. So I've got a little bug in there somewhere. So we'll exit out of that. And we'll just load the serial monitor in again. And okay, so you can see our serial number is still there. It's reading it because it will read the EEPROM even though the EEPROM type is not set. It's still going to look in those address locations. And so we'll go back in 01X. 01X gives us the auto detect, and will bring us back to the main menu. Of course, I forgot to set safety mode off, so we'll do that. And now we'll exit back to the main menu. So actually, I'm going to do one more thing. I'm going to set the write mode, which is option 6 in our settings, and I'm going to set that to hexadecimal, which is option 4 here. And so now you can see up here in the status window, our read mode is still decimal, which is the default, but our write mode is hex. And so this is my preferred setup when I set an EEPROM up for the first time. And so we can go back to the main menu. And I'm going to save my settings now. And so if I choose option 7, this is save settings, and so it tells you the current settings will be saved to the EEPROM by default. I'm going to change the spacing on this. By default, the save settings are allocated to EEPROM memory address 1 through 4. Type S to save settings now, or X to exit. And so I'm going to type S to save, and the settings have been saved. And so what this does is now when I open up the options menu for the first time, it's going to automatically go through the auto detect to detect the EEPROM, and it's automatically going to retain my settings with safe mode being off, the read mode being decimal, and the write mode being hex. And so we'll prove that by closing out the window and reopening it. So we're still going to go through this. It's still going to look for all the I²C devices, but now we're doing an auto detect automatically. And you can see safe mode is off, read mode is decimal, and write mode is hex. And so that's exactly how I want it. So that goes through the save settings. Now a range write is, well, basically the opposite of the range read, where we're going to write to a range of cell addresses with a specific piece of data. So let's see, we're going to 8, and why did I go to settings? No, I want 8. Did I type 0? Okay, so range write. So I'm going to type a range using the start, end, and data commands. So S, E, and D, just like a range read where we used S to start and E to end. But now we have another command is D for the data. So we're going to start at, let's see here, let's start at 8 and end at 15. So the data is D. We're going to write is going to be 44. And so it's going to write from 8 to 15, 44. And so if I do, and just read that back to me, but if I do a range read, and let's actually start at 0 so I can show you something else while we're there. And at 15. So you can see from 8 to 15 we've got our 44s, and then 0 is our 23 for our automatic detect, and then we've got a 1, which is telling auto detect that from our save settings, auto detect is on, safety mode is off, our read mode is decimal, our write mode is hex. And so that's these first 5 bytes to do the save settings. And so I think that brings us to pretty much a conclusion here. Let's go. We're going to do the ST to EEPROM in a separate video on its own. Of course, I can erase the EEPROM. Maybe we'll do that in just a second. Go back into settings. And let's see. So, okay, we can manually set the EEPROM type. Let's show you what that's all about. So you go into option 2 there, set the EEPROM type, and you can choose an option. You've got all the way from 1 kilobit up to 2048 kilobits that you can choose, and of course, if you want to add more or different ones, you can certainly do that. But these are the most common ones that I found through the microchip and Atmel websites. These are probably the most common ones you're going to come into contact with. And so we've already got our EEPROM set, so we can just exit. Oh, there's something else I wanted to show you. Set EEPROM address. So we have 8 EEPROMs on the board. We've only been working with the first one here in address 0x50. But if we wanted to work with one of the other ones, we would have to change to that EEPROM's I²C address. And so this is where we would do that. And so let's go to 1, which is address 51. And you can see, you heard that little thing. We changed the address, so now our EEPROM, this one has not been set. This is a brand new EEPROM that does have, I wrote a serial number to it earlier, and it has no auto detect, set write mode, that sort of thing hasn't been done yet. And so our read mode and our write mode hasn't changed, because that doesn't change when you change from one EEPROM to the next. However, we can set the write mode, we can set the, exit back to the main menu, save settings, but actually first we have to set it up, don't we? So we'll do the auto detect, and it found the 256K bit EEPROM, and then we're going to turn safety mode off. Oh wait, it was off, that's right. So, yeah, that's right, that's correct. And so now we can exit back to the main menu, and we can save our settings on this EEPROM, and type S for save. Settings have been saved. And so now, when we go back to set EEPROM address, and we switch back to our first EEPROM in address 50, we're going to get, that one's going to be auto-detected automatically. And then if we go back into 51, that one should be auto-detected automatically. There we go. And that's address 51. And so I think that will do it for this video, except for one thing. We'll go back to our main menu, and we'll erase this second EEPROM here. So we're going to type E and then type E. And of course, if you knew you wanted to erase it, you just type EE, and then that will erase it without having to type enter twice. So it's going to erase the EEPROM. It's going to zero it out, every address. It's going to erase all of our save settings. It's going to erase the auto detect identifier in address 0. It's going to erase our serial number course, it's going to erase any data that may have been in between. And this does take a little while, depending on the size of your Eeprom. It's a 256K bit, like I said. The 64K bit would be done now. It only has 8192 bytes. And of course, I'm looking forward to getting some larger EPROMs, maybe some 512s, some 1024s, and a 2048, so we can test the higher ones. But I think I'm gonna leave. Well, I might as well let this finish out. I don't know if there's anything I can really talk about while it does it. Maybe I'll just try to speed it up instead of letting you here wait, watching another 15, 16, 17,000 bytes go by. I guess one thing I could mention is because I'm not gonna slow this down. You're gonna have to speed it up or skip through this. But there's one thing I do want to mention is that it will not overwrite a 0 or any other data if it doesn't have to. So we're not gonna waste a write cycle if we don't have to. So if the information is already 0, it's not gonna overwrite to overwrite another 0 and then waste a write cycle. Of course, these things only have about 1,000,000 write cycles, which may or may not be enough. The data retention on them is variable. So, as in for the 24LC64, the microchip 24LC64, you can see we've got 1,000,000 erase write cycles, and it has a data retention of 200 years, which is pretty impressive. But if we go to the Atmel C256C, we can see that data retention is only 40 years, which is, I guess, still pretty acceptable, with the same amount of 1,000,000 write cycles. But yeah, so each one has their own specified. Of course, I'm less apt to believe that microchip is got 200 years experience to verify their claim. But regardless of that, I guess that's okay. So okay, we are done. You can see we have written to all 32,768 bytes, and it's all zeroed out. And that was our second EEPROM. Let's go back to our first. That one is still auto-detectable because our save settings have been saved. And okay, that's kind of the overview of what we can do. Like I said, I'll get back to the SD to EEPROM in a future video. Stay tuned. We'll catch you later. Bye.